Okay, so quadratics today. That's all we're doing this whole chapter, quadratics. It's basically our parabolas, x squared, quadratics, parabolas, x squared, okay? So our common core is A for algebra, R is reasoning, E for equations or inequalities, 4B. So 4B, what is it? It's just basically solve quadratics equations by, and then if you look at the standard, it gives all of these things: completing the square, factoring, quadratic formula, blah blah. It gives a lot, but today we're just going to do the one, and that's by factoring. Factoring is the easiest if you can factor. It's the easiest, the fastest if you can factor. If you can't factor, there's other ways to do it, which I'll show you. Okay, so first of all, zeros. Here it is. Any value that makes a quadratic equal to 0. Okay, they're also x-intercepts. We talked about that, right? So it's any value that makes a quadratic equal to 0. They're also x-intercepts. Okay. So now example 1. So find the zeros. So set it equal to 0. So we set it equal to 0, saying, okay, what values are going to make it equal to 0? X squared plus 2x minus 3. Now, if you can factor, it's easy. If you can't factor, there's a lot of other ways to get it, but all of the other ways are hard. Factoring is the easiest way, if you can factor, okay? So factoring, you just go, parentheses, 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 right? And the only way I'm going to get an x squared is with an x and an x, right? Now, what about the multiples of 3? What times what makes 3? 3 and 1, right? 3 and 1. But how about a positive 3 and a negative 1, okay? Does that make sense? Now, the zeros are almost there. The zeros are what makes it 0, okay? Now, one way you can do it is just do it in your head. Say, well, wait a minute. Isn't 1 minus 1 0? So one answer would have to be 1. One answer is x equals 1 because 1 minus 1 is 0, right? And the other answer is x equals negative 3 because, negative 3 plus 3 is 0. But if you don't see that, then just make two little mini equations. You're going to have an x plus 3 equals 0 and an x minus 1 equals 0, and just solve, okay? And we will get the same answer, right? Solve minus 3, subtract 3, one answer is negative 3. Hey, what do you know? I told you so, right? The other's plus 1, x equals 1. What do you know, okay? Now it says check your answers. So I'm just going to do it with my calculator. I want to show you, okay? So to check my answers, I'm just going to take my 3, plug it in, and I'll take my 1 and plug it in, okay? Plug it in. I'll do the same thing. I'll just plug it in, okay? Let's see what I get. So I'm going to take my negative 3, right? And I'm going to go clear. And we'll go parentheses, negative 3 squared plus 2 times negative 3, subtract 3, and I get 0, okay? It's got to be 0 because anything plugged in that makes it 0 is a 0, okay? So let me check my 1 squared plus 2 times 1, subtract 3. Sure enough, 0, okay? So we've just verified that there's 0, say. So anything that makes it 0 is a 0. That makes sense. Okay, example 2. Right, same thing. If we want to find the zeros, set it equal to 0. 0, set it equal to 0. 0 is equal to x squared minus 8x plus 12, right? If I can factor, I'm going to factor. For me, it's easier, okay? And it will factor, okay? What are the multiples of 12? What times what makes 12?
6 and 2.
6 and 2 is the right combination. If you use 3 and 4, it won't make an 8, right? If you use 3 and 4, it won't make an 8. But 6 and 2 will. Good job, Will. So I'm going to go x minus 6 and x minus 2. Because together they will multiply to make a positive 12. And together they will add to make the negative 8. Okay, so then I know my answers. Already my answers are x equals 6 and x equals 2. Because if we put a 6 in here, 6 minus 6 is 0, right? If I put 2 in here, 2 minus 2 is 0. Those have to be my zeros. But again, if you don't see that, you can set them equal to 0 and solve them. Get little mini equations, right? If you want to solve them, you can. That's another way to do it. Plus 6 plus 6. Hey, that's what I had, right? What do you know? Okay. plus 2 plus 2. There you go, okay? Not too bad. I think the hardest part about today is just, can you factor? And hopefully you'll learn that in algebra. Maybe, okay? Okay, example 3. This is that other kind of factor, okay? When I look at example 3 right off the bat, I know one of the answers is 0 because 0 plus 0 is 0. One of the answers has to be 0, but let's show why it is. So we're going to set it equal to 0 because we're trying to find the 0. Set it equal to 0. 3x squared plus 12x. Now, we're going to common factor. Okay, common factor. So when you common factor, you say, what do they have in common? What are the multiples? Well, they both have a multiple of 3 in common. So you write it down. They both have a multiple of 3 in common, and they both have at least an x in common. They both terms at least have one x in term, so I take out the x that they have in common. So if I pull out the 3x here, I'd have just an x left over, okay? And if I pull out a 3x here, I'd have a plus 4. Now, if this confuses you, you can check to make sure you're right. Because it's just the opposite of going this times this times this. So if you want to check to see if you did it right, that times that makes a 3x squared, good. And that times that makes a 12x, right? So I factored it right, okay? Now, let's set it equal to 0. So I've got a 0 equals a 3x, and a 0 equals an x plus 4, right? Divide by 3, and x is 0. 0 divided by 3 is 0. And that is an answer. That's a number. Minus 4 minus 4, I get negative 4. Those are both my answers. So one of the things we're seeing, Gage, you were right, 2 answers, right? In fact, all the way through here, we keep getting 2 answers, right? We need to get 2 answers because it's an x squared equation, okay? And you can see it from factor, okay? Thumbs up so far? If you can factor, you're good, right? If you can't factor, you're in a little bit of trouble. Yeah, Will?
How do you know when to use instead of...
Right. So if you take a look at the 12, can you take an x out of the 12? No. So normally when you common factor, they have to, all the terms have something in common. Okay? Turn the page. Okay? Example 4. Find the roots. Now roots pretty much for us are the same question, okay? It's the same question. Roots, zeros. So think the same thing. Roots and zeros for right now mean the same thing. When we start to introduce I and imaginary numbers, then we're gonna see a difference, okay? So set it equal to 0, right? Can you factor that? Yes. Say it, Gage. Yeah, it's just x plus 3, x minus 3. You guys agree? Right? So would you agree that x would equal a 3 and x would equal a negative 3? Does that make sense? Carlos, how you doing back there? I know you guys had a late night, didn't you? Yeah. Okay, now we're going to make it a little bit tricky. Example 5. It's not ready to be done yet because you have to make it equal to 0. You have to make it equal to 0. So I'm going to take the 40x, I'm going to put it right there, right in the middle, okay? Because I like it to be x squared, x number, okay? X squared x, so I'm going to take the 40x, put it there. How do I bring the 40 over, though? How do I bring the 40x over? Yeah, good, Joseph. Subtract it, right? So minus 40x minus 40x. So what I'm going to have is a 0 equals 8x squared plus a 40x plus 50. Okay, now those are big numbers, right? Those are big numbers. Maybe I can make it easier. Yeah, Austin, what do you see?
Would it be minus 40x?
It sure would. Thank you for catching my dumb mistake. Appreciate that. Thank you. Now, 8, 40, and 50, those are big numbers, right? I'm going to show you a trick. It's a cool trick. Because it equals 0, if I divided both sides by 2, it would just reduce it, right? So if I divide everything by 2, I'd have 0 equals 4x squared minus 20x plus 25, okay? Well, let's try and factor this. Let's give it a try. Let's go parentheses, 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 okay? Okay, I don't know about the 20, but I do know this. To To make a 4x squared, how about 2x, 2x? Okay with that? So how about 2x and 2x, okay? I still don't know where the 20 is going to come, but at least I know that, okay? How about the 25? How are we going to make the 25? 5 and 5. You guys agree? 5 and 5. Now, where's the 20? Well, let's look at that double smiley again, right? Remember the double smiley? Yeah, you see it, don't you? 10 and 10. 10 and 10 make the 20. But I need a negative 20, so what am I going to do? Get a negative 20? Negative and negative. They're both negative, aren't they? Nice job. Now, those aren't the answers, but it's factored, right? So if I take my little equations, I got 0 equals 2x minus 5. And, of course, same thing. I'm just going to solve. Take this, set it equals 0. Take this, set it equals 0. And then I'll solve it. Plus 5, plus 5. I get 5 equals 2x. Divide by 2, divide by 2. 5 divided by 2 is 2.5 equals x. And we should get the exact same answer here. Now, it's a technicality, okay? Just a sec. It's a technicality. We still got two answers. We got the same answer twice. This is called a double root. Double root, because we get the same answer happen twice. So it doubled up, okay? Will, question?
How did you graph that then?
Oh, great question. How do you graph it? Okay, so it looks like this, right? In theory, it goes through the point and back up. So it goes through the point and back up. So in theory, it touches it twice. That's why it's a double root. Does that make sense if I do it like this? Okay, really good question. Somebody else had a question. Okay, moving on. So now, example 6. Find a quadratic equation in standard form if the zeros are x equals 2 and x equals negative 1. Okay, well, if I got an answer of x equals 2, that had to have come from an x minus 2 equals 0. I'm just going backwards, okay? If I got an answer of 2, that had to have come from an x minus 2 equals 0, right? If I got an answer of negative 1, then that had to have come from an answer of an x plus 1, right? Well, let's back up. Let's put them together. So really, we could have had an x minus 2 times an x plus 1, right? And that would equal my f of x. Okay, that's the answer, with one small exception. Once in standard form. Once in standard form. So we're going to have to multiply it all out to get an answer, okay? So x squared plus 1x minus 2x minus 2, right? I can combine these two x's, right? So I would have an answer of f of x equals x squared minus 1x minus 2. So if we were to factor this and solve, we'd get those answers, wouldn't we? Right? If we were to take this, factor it out, and solve it, we would get these two answers. It's kind of like Jeopardy. I gave you the answer, we came up with the question, right? Okay, last but not least, okay? Number 7. So a soccer ball is kicked from the ground and follows the path given by the equation h of t equals negative 16t plus 32t plus, I'm going to put 0 here. I'm going to put 0 because it's going to make it easier for me to put a graph, okay? So this ball had to start on the ground because of the 0. And I'm just going to go like this. Right? Boom. Did you agree with that? Goes up, comes back down. Everybody good on that? Now we're missing some important numbers, aren't we? So first of all, find the height and that time. Now the height is here. What's that point called? The vertex. Now the vertex is found by our negative b over 2a. So this is what we did yesterday, right? Right? This is what we did yesterday with negative b over 2a. Thank you, Gage. So let's do what we did yesterday. So negative b over 2a is going to be my negative 32 over 2 times my negative 16, which is 32 over 32, or x or t equals 1. So here's what I know. I kick the ball. At 1 second, it's at its highest spot, right? It's 1 second, it's at the highest spot. How high is that? What's that height? Let's plug it in, right? Let's plug it in. So if I plug in the 1 and take my h of 1 is equal to negative 16 times 1 squared plus 32 times 1, I think I get 16. Yeah, I do. I get 16. So here's what I know. I know at 1 second, it is at 16 feet high. All right? That makes sense to me. Goes up 1 second, it's up the highest. Now, because parabolas are symmetrical, we could do this problem in 2 ways. Okay, you ready? When does it hit the ground? Yeah. Now we could set this equal to 0, factor out a negative 16t, and have a t minus 2, and we would get t equals 0 and t equals 2. That's the math. But let's use some common sense. I mean, it's just perfectly symmetrical. 1 second it's at its highest. Totally right, Will. At 2 seconds it hits the ground. And I got the math to back it up, okay? Does that make sense? Okay, so homework, and you did a really good job. I'll take this down to 0 again, but yeah, I sure will. Let me stop my recording.